Okay, so if there are no questions, we can look if everything holds what I've promised. So I had some requirements at the first thing. The first one was an untrusted server, which we of course have fulfilled because we only need the server as in Blackboard. And the only assumption, to be honest, is on the server is he has to hold every message back before everybody voted. So what could occur is somebody cooperates with the server and gets the message before he votes, and then he can see the sum before he votes. So he can see the result before he votes, but he also cannot break our privacy. But he can do this one. If we want to get this assumption away, we have to use one more communication round where everybody encrypts his vote, sends it, and afterwards decrypts after everybody has sent his unencrypted. But we have no other assumption on the server, and I would say it's for the privacy, it's really no problem. It's really good. So the next thing was the privacy, and I think we have fulfilled it as well because nobody sees who has voted for what. Only our attacker model was that n-1 has to cooperate, and if n-1 has to cooperate, we can calculate our vote with any scheme because then we can just subtract the sum of them and then we have our vote vector, so it's not possible in other way. So this verification we have achieved with splitting the vote, first the -1 voters and then inverting it and therefore avoided the +2 voters. So the communication steps, we have the same as in Doodle, so we have, as you calculate 3 or 1.5 if you calculate it in both way, communication steps. And for the computational complexity, we have a scheme which scales in the number of dates, so it's we need p-1 asymmetric operations per voters, which is one Diffie-Hellman calculation for every other voters, for every other voter, and that's it. So the other calculations are all symmetric, which are really cheap. So, are there questions?
You still need a trustworthy server?
No. So it's the thing, the question, what is the trust you place in your server? So for the privacy, you don't need any trustworthy server. But for, yes, only for this, you can see the sum, what is, of all votes before you vote.
And the server can manipulate the result.
Okay, if you mean this one, therefore you do not only need a trusted server because every attacker who can manipulate the line can just add 1 to your encrypted vote vector, and then so we have this vote vector. Wrong. Here, and no, I do not mean this one. This one. And everybody can add a 1 here, and this addition of 1 here would add up a 1 here, and would be then make from a 0 a 1 or from a 1 a 2. So this can be done by everybody, not only from the server. But I avoid this with everybody signs just his vote vector, and everybody checks this afterwards.
But you still have to trust that the server correctly computes the sum.
No. Because you get only all the vote vectors. You check if these vote vectors are correct by checking the signature of Bob here and Carol's signature here, and afterwards you can do the calculation your own. Okay. But it's good that you think. There. No, here. Yes. So, are there questions? So then okay.
Feature request, so to say.
Okay.
If we want to implement the policy, then legally some people are more equal than others, so they have more right, if they say, maybe the...
Yes, okay, I wanted to come to this later on. I have this feature also inside, this feature request. In my Outlook, I have some features which I want to have later on, but I have some solution for this. Okay, so I partially implemented it. It's pre-alpha state. And you can achieve this at, I wrote this at doodle.inf.dresden.de because I'm coming from the Institute of Datenschutz und Datensicherheit. Yes. So you can achieve this here, and there should be any link. No, I forgot this link there with privacy enhanced. So you get the privacy enhanced version, and you can try this. But it's not everything implemented in it. But for example, we have the meeting, and we create some poll here. And everything is implemented in JavaScript. So it should work with any browser who is applicable of JavaScript and HTML5. So you need HTML5, sorry. I can show you for what later on. So, and we configure some dates, so some time slots, the 30th and the 31st. And here we have to invite some participants. Of course, I show the user strings for this, but when we look into the source, we will see that that we have behind this, we have to send the public key, or this is the fingerprint actually of the public key from Alice. So, and sending this, we configure, okay, Alice wants to participate, and Bob as well, and maybe Carol. And afterwards, we send this link around, and everybody goes there. And then you have this scheme, which is quite the same as in Doodle, and you can say, okay, on this day, and I submit. And what happens after when I press submit here is, in the background, there was already a calculation of this vote vector for this time slot. And when I press submit, it just submits these vote vectors to the server. So, and we can look now into the server here. Yeah, make it bigger. So, and when we look here, you see, okay, yeah, here is it. This is the vote. So this person with this key voted for these three columns, and the first was this long number, and the second was this number, and the third was this number. So you cannot see anything from this. So, and when we now, when we go now back to this, and of course I log out as Alice, and I log in as Bob, and you see here as password currently you have to give the secret key, which is quite long. This is a bit of a problem. Yes, I'm not sure how to solve this, to have here really a short seed and calculate from this short seed the long key. There are several ways to solve, I know, but yes, I'm not quite happy. So, and when I log in, it's not a login. I've only made such a login to show the normal feeling a user has. So the only thing which was done now was calculating from this secret key we entered here, so the public key, which is this one, and fetching this modular, and just an initialization, so there's no server round trip with this, pressing this. But now we can go to the meeting, and the browser detects that I'm Bob and calculates the keys in the background. And while it's calculating, of course, I can just vote. And yes, you see JavaScript calculation is not very fast, but when it shows the submit button, I'm allowed to submit this. So, and now we too have voted, and we see, okay, now we want to kick out Carol because she is on holidays or anywhere, and we press this kick out button, and I'm asked, yes, do you really want to remove her? And when I press this button, my client sends the key from Carol to the server, and now the server has the key from Bob, so therefore it says, okay, there's the key from Bob. Bob wants to remove this participant. And I can go back, log out again, and log in as Alice.